Abundance and scarcity. When I was first presented with this theme, the economy was not where my mind went. Instead, I immediately thought about science, scientific education, scientific community, science in the general public, science in the media. Now, I had already been ruminating on this for the past year. How could I explore the issue of abundance of scientific information pervading throughout our society, yet the scarcity in its understanding and accessibility? How could I look at science and dance as both distinct fields and as complements to one another in the interest of learning, teaching, and sharing information? I started with the dance ensemble in mind, one part of the population. But could I expand this population to include another group? One I had never worked with at all, in any capacity. Enter students from the Galaxy Youth Program at Grinnell. With these individuals, I was to create and present a number of workshops that looked at specific scientific concepts that we could observe, analyze, learn, and dance to. But where within the scientific realm would I start my project? I thought back to where my ideas for this research had originated. DNA. As long as humans continue to exist, DNA will exist with us and play a prominent role in scientific learning. And while it exists so simply, so quietly within our bodies, the scientific and cultural media have created an image of DNA that is extraordinary, powerful, even frightening. DNA might be fundamental to life, but many find resistance to it, which inevitably leads to resistance in other scientific matters. And perhaps, one finds that their understanding and fascination for DNA increases. This could lead to similar outlooks for other scientific concepts. DNA. This seemed like a worthy place to start, and so I began my first workshop. With the dance ensemble, I presented an exercise that used 5 images of DNA. I asked them to observe the images, noting characteristics, properties, and descriptions of each image, and create movement from these observations. In the end, each dancer teaches a spectrum to share. With the students from the Galaxy program, we conducted a similar workshop. We all began by standing in a big circle, and we introduced ourselves with movement. We introduced creative movement by finding ways to make shapes with our bodies, and looking at negative and positive space on different levels. Then, we looked at the definition of DNA. Deoxyribonucleic acid, DNA, is a nucleic acid containing the genetic instructions used in the development and functioning of all known living organisms. The sentence packs a punch, so we looked at the words that seemed familiar. Contain. Instructions. Development of all known living organisms. Functioning of all known living organisms. With this workshop, everyone involved could focus on what they did understand, rather than hesitantly focusing on the words they didn't understand. A lot of these workshops used improvisational elements to gather movement material. One day, I brought in a video of mitosis. And asked the dancers to embody the essence of the movement they had seen. How could they focus each detail from the moving image and use it in every single part of their body? Using this as a warm-up, we looked at mitosis in its 5 phases. Have a Nice DNA by Fran Balkwil and Mike Rolfe. What happens next in a cell with 2 copies of DNA? Well, the cell rests a while. Copying DNA is hard work. Then the DNA strands get shorter and fatter. You can see the individual chromosomes. The chromosomes line up in the center of the cell. They are attached to very fine cables. Each chromosome breaks into two halves with identical DNA. The two halves are slowly pulled apart by the fine cables. The cell begins to split in half. This will make two cells with identical DNA instructions. We had made the still images come to life.
Good job. Very nice, very nice. Very, very good.